This slide shows the response over time for the circuit that we considered previously. So here I have the equation that we saw previously that we solved for. We had Vc of t is equal to Vs minus Vs e to the minus t over tau. So again, Vs was the voltage source that was being applied to charge the capacitor. Tau is equal to Rc, so of course that depends on the circuit components as well. And so what we see then is that, of course, again, we have a decaying exponential here. So as t goes towards infinity, this second term is going towards 0. So ultimately, our capacitor voltage is going towards this final value of Vs. We talked about as well that we had some initial value for our capacitor voltage that was 0. We said it has to be continuous. So we get an overall curve that looks like this. I want to talk about the terminology for these different parts of our equation and these different parts of our plot. So for our capacitor, as we are charging this up, we have two parts of our response. We have our forced response, which is named because our voltage is being applied or forced on the capacitor. So this is our Vs from the source. And then we also have our natural response, which is the decaying portion of the response to that voltage. We could also look at our plot down here, and we can divide the response into two general areas. We have our transient response and our steady state response. And so this comes back to, of course, the title of the chapter slides are transients. We're looking at RC transients, RL transients. And so mostly what we're focusing on then is this response right after our switching. So most times we'll indicate that's at t equals 0 just for convenience, but we're looking at the response right after switching. This transient response corresponds to our total response, and so let me just write that up here so we could say that this Vc of t is our total response. So our total response is the sum of our forced and our natural responses. So we can say then that our transient response is the response when our natural response is relatively large. So when our natural response is still in play, we're talking about this transient region. Once that decays to a negligible value, we're now in the steady state region, right? So once this forced response becomes more dominant, we're now in our steady state. So the notation will vary slightly depending on the source that you're looking at, but this is the same notation that you'll see in the Systems and Controls class in your junior year.